things. We do there's our inbred lines, we manipulate them as such with hormones and whatever else so that they come out and they're self-incompatible. There's three ways that we typically do this. One is self-incompatible, or what we call SI. And a self-incompatible plant wants to have sex with another plant. But if there's no other plant around, it will go ahead and take care of the deed itself. The next way we do that, and once again, it's introduced in the inbred line. We have what we call male sterile. This is the, or MS, this is the equivalent or the version, the plant version of a vasectomy, where you can still have all the same apparatus, but you have no pollen. So there'll still be male flowers, but there's no pollen. And then lastly, there's the conversion. And on the conversion, we actually spray plant hormones onto the female line, which makes them abort the male flowers. So, just a quick illustration here. This is a cabbage, and it's an SI, which means self-incompatible, which means also note, anytime you see stakes in a field and strings, those are to prop up the females and make them look really pretty. And you'll also notice that the males just kind of flop around all over the place. This particular nick on this cabbage has a problem because the females are starting to bloom a little bit earlier, just worried about pushing the wrong button, a little bit earlier than the males. And you can see one or two blooms on these males, but not a lot. So as soon as this picture was taken, we went through the hedge trimmer and got rid of the females on that, which it was only a 3-acre field, so it didn't take very long. Anyway, that's what happened there. This is the same variety of the first picture I showed you, and you can see the stem in the foreground is the lighter colored and the darker with the females in the back. This is a great nick because you can see this thing is just coming into bloom and the male is blooming first. So there's the female ready to rock and roll. And here they are coming out of bloom. You can see the male still has lots of bloom on it, and the female is just finishing up. So life is good. Side note, what do we do with the males as soon as we're done with them? As soon as they've served their useful purpose, we rip them out, turn them upside down, they dry up, they wither, we tromp them underground, and they have no value. So I was hosting Leadership Albany one time, and I explained this whole process, and this woman, I kid you not, said, raised her hand, she goes, "Mr. Craig, do you ever envision a time when we won't need any males at all?" Anyway, the next way we keep the females from pollinating themselves is the male sterile lines, and that's the vasectomy thing I was talking about. If you look at this picture on the right, this is a hybrid red round radish seed. This is your male line here. It's a little bit pink, and then the green over here is your female line. Those females are full of flowers that are male flowers, but they have no pollen in them, so we call them male sterile. And the same with these onions here, and of course, the ones that are staked up and strung up, those are the pretty ones that we're going to keep, and then the males just sprawl around. You can see some bees getting ready to pollinate there, so life is good. With vine seeds, and vine seeds are, we call them wet seeds or vine seeds, those are like cucumbers, pumpkins, squash, zucchinis, all those kinds of things. They're grown inside this slimy carcass that the seeds are, and you got to break them out of there. We call them wet seeds or vine seeds that way. This is a cucumber, and the one on the left is the male line of a cucumber, and it's a monoecious plant, which means it has male and female flowers, and typically a monoecious plant will produce 10 to 20 male blossoms for every female blossom. And then the one on the right is the female line, and that one is a gynaeceous plant, which has far more female fruit and not nearly as many male, sometimes none at all. But with this particular one, it did have some male flowers that were coming on it, so we would spray like a gibberellin or plant growth hormone at 3 to 5 applications at a certain time of the year with certain parts per million to abort the male flowers, so that we could, when we harvested that seed, we would only get the hybrid. This is all very fascinating, I can see. Okay, moving on. In the 1980s, researchers developed the more precise and controllable methods of genetic engineering to create plants with desirable traits. This genetic modification involves 1 to 4 pairs of genes, whereas the conventional breeding mucks about the entire genome in a trial and error way. The company that we grow cucumber seed for, the plant breeder that breeds the cucumber seed, she's an amazing person, one of the smartest people around. She has these greenhouses that are just full of different cucumbers. She will look at over 200 varieties of cucumbers every year, and that's only pickles. It will take her well over 1,000 attempts to come up with one release. Talking about millions of dollars and years and years and years to get one release, one that you can go and buy your little seed package at Tom's Garden Center that says whatever brand it is, pickle cucumber. Where genetic modification truncates that whole process, and all those, there might be 10,000 to 300,000 gene pairs affected with conventional breeding, where there's only 1 to 4 in genetic modification. Specific transgenic insertion of a desired gene so that's how they do it. This is GMO in a nutshell. Where you're taking one certain gene, one that makes it resistant to drought, one that uses less fertilizer, one that resists disease, or one that has BT in it so it can kill something. They know what that gene is. They've identified it, and they inject that into that strain, and so that's what happens. And in the 1980s, these first GMOs are introduced in the marketplace. And now, everything I've told you so far is true. Everything I'm about to tell you, I believe is true. Somebody's going to ask me, hey, what's your opinion on GMOs? So I'm just going to tell you. And nobody has to agree with me. I really want you to consider the possibilities. And I really believe what I'm about to say. If you look up GMO on Google, which you all do, because you Google everything, this is what you'll see. You'll see tons of pictures with tomatoes with hypodermic needles stuck in them, which is really interesting. They're not GMO, those tomatoes. Anyway, there's only 8 crops presently released for production as GMOs, and those are canola, sugar beets, corn, soybeans, papaya, which we wouldn't have if we didn't have GMO, cotton, squash, and alfalfa. A lot of people in this room aren't eating a lot of cotton or alfalfa. Anyway, there's that. But those are the only 8. So when people say, "Oh yeah, that GMO wheat," that's just not true. GMO tomato didn't happen. It is worth noting that no commercially available crops in the United States were created by nature alone. So when we talk about the natural things, the things that are natural, we would be starving to death if we were doing the natural thing. And tomatoes aren't on this list, but these tomatoes with all the needles stuck in them, they may be diabetic because insulin comes from the same process that we do genetically modified engineering on crops. So you don't have to crush the pancreases of cadavers or dead cattle or anything like that to get your insulin. There's a lot of people in the world right now, 7.2 billion people in the world. There's going to be between 9 and 10 billion people in the world by 2050, not 15, 2050, 35 years from now. A lot of people want to argue that fact because the birth rates have dropped and we're almost neutral. So if we have 7.2 now, how are we going to get to 9? Well, the biggest issue is, yeah, there's the same number of babies being born, but the infant mortality rate is totally different. So babies are living. And I would argue with you that that's a good thing. 9 to 10 billion people, can we feed them? Well, yeah, there's lots of food for those people who can afford it. And you see, we won the ovarian lottery. You people in this room, we live in the United States of America. This is beautiful, this produce that we see at our grocery store. You walk in there, it's getting squirted with misty water, it just shines, it sparkles, and it's the coolest thing ever. And this is our access to food. And it doesn't matter what time of the year anymore. In the old days, that mattered, but not anymore. Because we're getting food from all over the world, and who knows where it comes from or how it's grown, but that's all beside the point. But the truth of the matter is, here's access to food. And if I'm too lazy to get a job, I can get food stamps, and I can still have access to this food, okay? Now, the plate in the bottom left corner, I just took that off their website of my favorite restaurant. It's down on First Street, and it's called Cerberus, and the chef, Matt Bennett, does a great job, and you get great value for low money down there. It's a great deal, and I think I'm probably going to get a discount if you guys can give it to me. You can tell I love food, and we're so lucky. We won this lottery. And I can't overstate that, because a lot of people, see, we spend 78% of our household income on food, and other countries spend up to 45%. And that's the average. So you know, some people spend 80%, and some people stand in line all day long to get some food. Recent study, 80% of the United States population think that all GMO presents in food should be labeled. The same study, 82% of the US population think that all DNA in food should be labeled. This is what we're working with. Daniel Webster says the world is governed more by appearance than reality, so that it is fully as necessary to seem to know something as to know it. We see this a lot. It happens to me. It happens to all of us. Even though we have our minds made up about something, we see something that we know is real. We know this is true. But the reality of the situation maybe is something totally different. So let's make a case for GMO. Or not. But I choose to make a case for GMO. Today's farmers produce 262% more food than they did in 1950. That's with 2% fewer inputs. Is that from GMO? Of course not. Is it from GMO to a degree? Absolutely. GMO's really contributed to that. But the truth of the matter is, we've been on this, and I want you to catch this, we've been on this technology progression for a long time in American agriculture. And we got site-specific, and we figured out how to use nitrogen fertilizers, and we figured out how to do site-specific agriculture, and we can do auto-steer, and we can really dial things in. We found efficiencies that we could never find before, and we're just about to find more. And we've also done it with genetics, because the truth of the matter is, you know, when my dad was a kid, 6-7 tons of corn was a good yield, and nobody in this room is going to be happy if it's less than 11 or 12. So we've doubled yields on the same acres, and so we're doing far more with less. GMO uses significantly less pesticides, fertilizer, and water because it's bred into the plant. We've actually taken genes and injected into the host plant. We've come up with a strain that is drought tolerant. It uses less nitrogen. They use 30% less nitrogen on the thousands and thousands of acres that they grow of canola, and it's more drought tolerant. And that's, I don't remember how many billion-dollar business, but it's big. We just don't want to hear. For another political reason. But there are huge advantages nutritionally, and I'll talk about that in just a second. There's a lot of noise out there. So there's the food pay, and there's all the Franken-food stuff, and a lot of it's done, you know, no, this is horrible, and it's all scare stuff, and it is scary, especially if you're a young pregnant mother that wants to do the best for your kid. I absolutely respect that. Economist magazine, 2013, they said the annual death, how many children from 5 years old and younger died from starvation or malnutrition? 3.1 million kids. During the exact same year, how many died from GMO? 0. This girl is blind, and she's blind not because she's starving to death. She's got food, she's got plenty of food, but she's malnourished. And she's been eating, her diet consists mainly of white rice. Her problem with her blindness is the vitamin A deficiency. And this is a problem. This is a big problem. And there's an answer, and that answer is called golden rice, and it's a GMO product. And it's stocked full of vitamin A. So she doesn't have to be blind, but it's a little too late for her now. But anyway, it's available, and it's free. And it's been on the shelf since 2002 because paranoia and fear sells more product than science or being a functioning member in society, I guess. I'm a big organic fan because I'm a capitalist and I love free enterprise, and if somebody wants to pay me something more for something, I'm more than happy to produce it for them. I don't have any organic production myself, but people I'm associated with do. So I don't want to bash organic, but I've always wondered when did the organic market become the anti-GMO movement? Because it seems to me like they could go hand in hand. In 2011 in Germany, a bunch of people ate a bunch of bean sprouts that were infected with E. coli, and it came from animal manure, of course, and the same number of people that died in Chernobyl died from bean sprout poisoning. and over 3,500 is